All right, let's dive right in. Over on the VoxStar Pulse, a story just dropped that sounds like it's straight out of science fiction. We're talking about a new AI-designed enzyme. Get this, that can consume an entire plastic bottle in a single day. Yeah, you heard that right. Consume it.
I know. It sounds totally made up, right? But it's real. And that's really the big question we're going to tackle here. How in the world can a tiny little protein eat something as tough as a soda bottle? I mean, these things are built to last forever.
So, to get our heads around how to break plastic down, we've got to first understand how it's built. It's like, before you can take apart a giant Lego bridge, you need to know how all the pieces snap together.
Okay, so at its very core, plastic is just a bunch of what we call polymers. Now, don't let the sciencey words scare you. All it means is you have these super long, repeating chains of molecules. And the Lego bridge analogy, it's perfect. Just imagine a massive bridge made of Legos, but, and this is key, every single brick is glued to the next one.
Now, the plastic you find in most bottles, that stuff is called PET. And the reason it's so ridiculously strong, the reason it'll sit in a landfill for centuries, is because that glue holding our Lego bricks together is just incredibly powerful. The chemical bonds are packed super tight, which makes that Lego bridge almost impossible to break apart using normal methods. All right, so if plastic is this nearly indestructible Lego bridge, how on earth do you take it apart? Well, this is where our hero enters the picture. And it's not some giant machine, it's something incredibly small. A tiny biological machine called an enzyme. And the way these enzymes work is actually pretty genius and really simple to understand. Think of it like a lock and a key. Every enzyme has a unique shape that's designed to fit perfectly onto one specific kind of molecule. It's just like how your house key is cut to fit only one lock, your front door.
So, here's the cool part. Nature actually gave us a head start. There are some bacteria out there that have enzymes that can kind of nibble away at plastic. The problem? They are so slow, painfully slow. But then, scientists had a breakthrough idea. They took all the data on this natural enzyme and fed it to an AI, and the AI did what AI does best. It analyzed everything and came up with a brand new design for the enzyme, basically supercharging it to work way, way faster.
So how does this new superkey actually work? It's basically a simple three-step dance. Step 1, find. The enzyme hunts down those specific glued spots on the Lego bridge. Those are the chemical bonds holding the plastic chain together. Step 2, lock. It latches right on, a perfect fit. And finally, step 3, snip. It kicks off a chemical reaction that just snips the bond. You can seriously just picture it as a tiny pair of molecular scissors. And this happens again and again and again. That massive, super strong Lego bridge gets snipped apart, piece by piece, until there's nothing left but a pile of the original individual Lego bricks. That long polymer chain is just completely taken apart. So, what happens when you break all those chains? Well, the plastic isn't a solid anymore. It literally dissolves into a liquid. And here's the real magic. That liquid is made up of the pure, original building blocks of the plastic. This means you can take it and make brand new, pristine quality plastic over and over and over again. Okay, so this is where it gets really exciting. Because this isn't just some neat lab experiment, This has the potential to be a total game changer for how we handle plastic waste across the entire planet. So let me break down why this is such a big deal. Right now, our recycling is, well, it's not great. When you recycle a plastic bottle, the plastic gets weaker, the quality goes down. You can only really do it a handful of times before it's basically just trash. But this enzyme process, it's completely different. It breaks the plastic down to its pure, raw ingredients, which means we could have something like infinite recycling. The potential impact here is just huge. I mean, it really comes down to 3 game-changing possibilities. First, that infinite recycling we talked about. But think bigger. Imagine we could use these enzymes to actually clean up the plastic choking our oceans. Or what about our landfills? Imagine turning mountains of plastic trash, stuff that would just sit there for centuries, back into useful material. What all of this is pointing to is a totally new way of thinking about plastic. We could stop seeing it as just disposable trash and start seeing it for what it could be, a valuable resource that we can use again and again in a perfect continuous loop. And that really leaves us with a powerful final thought. This incredible science shows us that sometimes the solutions to our biggest problems are hidden right inside the problems themselves. It's this idea that by understanding the chemistry of trash, we can turn a plastic problem into a circular solution. Ultimately, the key isn't just about destroying plastic, it's about completely reimagining its future.